Hello, welcome to everyone new to the channel. I definitely got a spike in traffic after Mark from Cracking the Cryptic solved one of my puzzles, and I'm very happy to have everyone here. I figured it's a good time to post a new live solve then, since I don't have a new puzzle ready yet, although I am working on one. So look out for that. But this live solve is a puzzle by Glum Hippo, who also goes by Philipp Blume. I believe that's his real name. Anyway, so this was posted on the Cracking the Crypto Discord server just a few days ago, and I thought it looked really interesting. So I thought I would try to solve it here for you guys. If you want to try it yourself first, feel free to check the link below. I'll have a link to directly to the puzzle, as well as where you can find it in the Discord archive, and an invite link to the Discord archive if you're not familiar with that, or the Discord server in general, in case you're not familiar with that and want to join. A lot of great people there, great community. That's where I post all my puzzles as well. So with that, let's go over the rules, because I've never seen this rule set before, although this is number 4 in a series. So apparently he's done 3 others. I think in the description he put a link of where those other ones were published. So you can go investigate that as well if you'd like. But I'm going to go over the rules now. So there's these diamonds between cells. They're either horizontal or vertical. And what that means is that these two cells have a specific difference between them. And that difference is equal to the first cell value in that row or column. So if it's on a row, it's in the leftmost cell. And if it's in a column, then it's in the topmost cell. So I'm just looking at the rules again to make sure that's everything. Yep, and then also all possible diamonds are given. So if within a row, say this were or let's give this row for example, because there's no diamonds. So if this were a 2, that would mean that none of the cells in that row that are adjacent have a difference of 2 between them. All right, and so I assume that negative constraint is going to be important, and I'm going to get started. So I think some obvious things to think about first is where would 9s go in the first column and the first row, because obviously any row or column without any clues, any row or column with clues can't have a 9, because there's no way there's going to be a difference of 9. So I'm going to start with that. Obviously these can't be 9 because there's a 9 given here. And then this can't be 9. This can't be 9, or this, or this. So 9 is going to be in one of these 2 cells. For the top row, we know 9's in one of these 2, so it's not here. Not here or here. Here. Sorry if you're seeing this faster than me. I'm just being careful. So it looks like it's in one of these 2. So that's kind of almost symmetric. So 9's here, 9's here. That's working so far. I think 8s are also extremely restricted, because if we did have an 8, then there could only be one clue, and it would be the 1, 9. So let's take a look at that as well. So obviously anywhere that there's a 9 clue, there could also be an 8 clue. But are there any additional? So this could be an 8, because as long as that's not a 1. The reason this couldn't be a 9 is because there was 9 given. This could be an 8. So it looks like these. So that's not overly helpful. It's kind of hard in this cluster around here to see what's going on, but I'll do my best to not miss anything. There's also, this could be an 8, because there's only 1 there. And if this were the 8, then we couldn't have a 9 here or here. Does that restrict the 9s too much? Not that I can tell. I mean, it would be 9s here. Right, not much to be gained from that. How about vertically, just to be sure? 8 can't be here. We could have an 8 here. Or here. Not looking good so far. Or here. And then, of course, anywhere there's a 9, there could also be an 8. All right, so maybe that's not the most fruitful way to look at this. I could look at columns with a lot of possibilities. So let me think about, so for a 1 difference, we could have 1, 2, 2, I mean, we could have a diamond between every single one, and then it would just go through 1 to 9. So the maximum diamonds would be all of them, which is 8 diamonds. So that's not super helpful. 2 difference, we could do, say, 1, 3, 5, 7, 9, and then, so that's 1, 2, 3, 4, and then, so all the odds and then all the evens. That's 3 more. So that's 7. So 2 has a maximum of 7. Or what if we just did like this? How many is that? That's a lot less. 1, 2, 3, 4, maybe 5. So how many do we have here? 1, 2, 3, 4. Any more that are particularly... Okay. So I think I might have to look at this cluster of these runs of diamonds. See if I can get anything from that, because I'm really not seeing, like, I'm sorry if there's something obvious that I'm missing here. There's only 2 givens. This given 1 doesn't mean a whole lot to me just looking at it. So this given 9 did restrict where these 9s could go, but I feel like I got what I could out of that. Okay, so let's look at what does it mean to have a run like this or a run like this. So, I mean, really, it just means they have, because these differences don't correlate to each other. These 2 correlate. So this has the same difference as that. So what's the maximum this diamond could be? Let's think about that. So if this were a 1 and this were a 9, could we have the same difference between them? Of 4, I'm guessing? Yeah, 5, right? So that would be a difference of 4. So I think that means that this cell is 1, 2, 3, or 4. Because if it were 5, thered be no way to do 1, 6, and then what do we put here? Can't go back to 1, and you can't go up to 11. So this is 1, 2, 3, 4. Are there any others like that? This one here, same deal. So this is 1, 2, 3, 4. I think this might be the way to go. Just looking to see if there's any other runs on the same row or column. So I got that one, I got that one. This one here, so that's a 1, 2, 3, 4. Actually, can this be 4? I think it has to be less than 4, because if it were 4, how would we do that is the difference. So if this were 4, we could make this, we can't make this 0, so we could make this 8, but then what do we make this one? How about 3? So 3 would go to 6 and then 9. So yeah, this is 1, 2, or 3. So that's more restricted. There's no diamonds against the leftmost cells. This row has 3 differences from 3 different numbers. Doesn't tell me a whole lot. Well, let's see. We could figure out what the... It can't be 8. Obviously can't be 9. It can't be 8 because we could do 1, 9, but then, you know, what else are we going to do? 7, we could do 1, 8, and then 2, 9, but then what do we put here? Nothing. So this is maximum 6, which I hate marking that many, but I don't know what else to look at here. So, okay, I want to look at this though. That's right, I got a little distracted, I'm sorry. So the maximum difference between these two would be a 1 and a 4. So the maximum difference is 3, so that's a 1, 2, 3. So now we have a 1, 2, 3, 4 in this row. Sorry if that went a little too fast there. this cell tells the difference between these two as a diamond. So if this were 4, there'd be nothing to put in these. Even if this were a 1, for example, this would have to be a 5 if this were a 4. So this maxes out at 1, 2, 3. So we have 1, 2, 3, 4 here. Which, I mean, obviously means this is 5, 6, 7, 8, 9, and these can't be 9 because we have these marked. So these have no clues at all, which is why they could be 9s. These both just have 1 clue. So they could be any of those values. If it were 5, we could do, for example, 1, 6, 2. Yeah, I mean, there's just too many options here. Well, we can't have a 5. If I put a 5 here, the maximum difference I could do would be a 1 or a 9. And either way, that's a difference of 4, and I can't put a 4 here. What about 4? What's my maximum difference? To a 9 is going to be 5, so that is possible. So there's no 5s here or here. Not really seeing what that means. Oh, I really felt like this would give more. Okay, well, can this be 4? There's a lot of... So we said this could be 4 because we could do, for example, 1, 5, 9. So these all have a difference of 4. And then, you know, or this could be... The 5 would have to be in the center, but this would be a 1, 9 pair with a 5. And then we need 2 more differences. So we could do, for example, 2, 6. Let's make that a pair, 2, 6. And then this could be 3, 7. And we even have 4, 8 as a bonus. Well, no, we don't have 4, 8 because 4 is the difference. Something to remember. So this would be 4, and then this would be 8. And I don't see a problem with that at all. So obviously if 4 works, we could do it with 3. I'm going to try that just in case I'm missing something obvious about 3. But I mean, 3 could be so many things. So we could be 1, 4, 7, or we could be 2, 5, 8, or we could be 3, 6, 9, or the other way around. And then these can be whatever, you know, if this were 1, 4, 7, this could be 2, 5, or 5, 8. Oh, sorry, we can't, if we're a 3 difference, we can't do 3, 6, 9. Yeah, that's not, well, this can't be a 1. Oh, this can't be a 1. Sorry for not seeing that. We can't be 4 because we'd have to be, oh no, sorry, we can be 4 because we'd be this way, 9, 4, 1. Really makes me want to prove that this is 4, but okay, can we prove this can't be 4? Because if we can, that's a 1, 2, 3 triple. I don't see why this can't be 4, but let's try it. So we know that it has to be 1, 5, 9. So this is 4. This is 1, 5, 9. I'm trying to prove this is not possible. Don't really see how that's going to work, but so this could be 2, 6, or it could be 3, 7. Let's just pick one. I'm just exploring. That's all I'm doing. I'm exploring. So this would have to be the, well, one of these would have to be the 8. Yeah, as long as I put an 8 here, for example, then I think I'm good, whatever I put into these other ones. Yeah, I'm at that. If it's provable that this can't be 4, I don't think it's happening yet. Okay, so this is 1, 2, or 3, and the difference is 1, 2, or 3. So if the difference were 1, this would be 2, 3. If the difference were 2, this would be 4, 6. And if the difference were 3, this would be 3, or 6, 9. Don't know what I was thinking before, but sorry. Let me do that again. 1, 2, 3, 2, 4, 6. Oh boy. 1, 2, 3, 2, 4, 6, 3, 6, 9 are the only possibilities there. And we know it can't actually, we can't have a 9 because we know 9's here. So that means 3, 6, 9 is not possible, limiting it. Can we limit 1, 2, 3 or 2, 4, 6 in any way? Not that I can tell. Okay, well, whatever this difference is also has to apply here and can't apply here or here. So if this were, yeah, if this were 3, I'm trying to eliminate the 3 because that would match up with the 1, 2. That's my motivation here. So if this were 3, and I'm trying to prove it can't be, I don't know if that's going to work. These have to have a difference of 3. So this would be 5, 8. It would have to be. Couldn't have the 6 or 7 here. So with that 5, 8, that removes 5, 8 from these. There's 3 from here. So these need a difference of 3. So, oh. Yeah, so that would make these have to be 1, 4. But these 1, 4, that leaves this 2, 4, 6. So that eliminates 6 from here. So that means this has to be 6. That's in no danger of being 3 apart from any of those. Have to remember the negative constraint here. So, well, let's see. Yeah, 3 can't be with 6, but that's fine. That's far away. Then we got 5, 8, which are 3 apart. 1, 4, which are 3 apart. 1, 6, or 4, 6, which are 5 or 2 apart. 6, 2 are 4 apart. And then 2 to 7 is obviously not 3 apart. And then these 7, 9 pair is not 3 apart. Darn. This 3 also affects this column, but I don't know much about this column. These 6s would place a 6 here. Okay, I'm not seeing any reason a 3 is bad here. In fact, it works pretty well, which is unfortunate. That's not the answer I wanted, puzzle. All right, gotta look elsewhere. There's always a 2 in one of these two. Because either it's 1, 2 or 2, 4. Doesn't really help me yet. Boy, is this tricky for me. Sorry if you're seeing something I'm not. I'm just trying to find what to do. I mean, I could try some other numbers here, but I don't think they're going to be as effective as 3 in narrowing it down. Like a 2 would be 5, 7 or 6, 8 here. 1, 3 or 2, 4 here. Like, there's just too many options. All right, well, I've placed 8s in all of these, but maybe some of them can't be 8. Yeah, okay, so this can't be 8. I already kind of went through this, but I forgot when I was pencil marking. This can't be 8 because I'd have to have 1 9 here. And that's not possible. This 8 would need a 1 9 here, and neither of them can be 9, so that's not an 8. This 8 would have to be 1 9, which does appear possible. Yeah, so this could be 8. And then these can be 9, so they, of course, can be 8. So what does that mean? Well, now the difference here is at most 2. So I actually proved what I was hoping to prove in a different way. So there we go. That's not 3 because we couldn't fulfill it with this diamond. So now we have a 1-2 pair. That leaves 3 4 from these two. What else does that do? Okay, I got my wish. So what does that mean? Okay, well, 1 2 here, we can... It means this can't be 9. We already knew this couldn't be 9. That doesn't actually restrict us any more than we already were. Well, this can't be 1, but it's kind of meaningless. What else does it do? Okay, well, we could look at this column. We looked at 4. What about 3? Okay, well, if one of these two is 4, these are the 2 runs that I was talking about. So we either have a 9 5 1 here, or we have a 1 5 9 here. Something that tells me is one of these is a 1. Something to point out is if this were 1 5 9, that uses 9 in this box, which means this can't be 1 9, which means that's not an 8, which makes that an 8 9 pair. I don't think I can prove that yet, but that's something to remember if I do end up putting 1 5 9 in here. 9 is here or here. All right, well, what can I learn about... I'm going to remove those for now. The ones here. This is on a chain, so... Unfortunately, they don't share diamonds above or below. I was going to say, like, for example, if these two had diamonds above them, then we would know that this would be a pair. No, we wouldn't know it was a pair. We know one of them was either a 4 or 5. Not sure what to do with this. Well, we've got 1s looking into here. So one of these is a 1. Is 6 actually possible? One 7, yeah, I think it is. 1 7 2 8 3 9. Absolutely possible. Okay, this column's more restricted than this column because we have the... I think we already saw that this could be 4 though, so I don't want to go through that again. Oh, I thought finding this 1 2 pair would give me more than it has. If this were a 1, that puts a 1 in one of these, along with 7 or less. Oh man, that doesn't do anything. What am I missing here? Okay, well, these are next to each other, and these are next to each other. So I can kind of say one of these is 3 apart, one of them's 4 apart. And same here. Trying to figure out what that means. These can't be 1. So actually, none of them can be 1. So let's take a look at. I'm gonna have to just play with this a little bit. So 2. Let's say this were if this were 2, then with a 3 or 4 difference, that's going to be 5 or 6. So then, if this were 2, the minimum here is 3. Couldn't be a 4 difference in that case. Could it? No. Okay, so that's interesting to point out that if this were the 159, what would this be? It's got a 3 difference, and it can't start with a 1 here or here. So it's going to be a 2. 258. Or 369. Oh, but it can't be. I have to remember 369 is not possible because it would be a 3 here. And then the 2 8s on either side. So that puts a 5 here. Just looking to see if that would be problematic. So in this case, this would be, this is the 4 and this is the 3. So for these two, we'd have 1 4. We couldn't use 2 5 or 3 6. 4 or 4 7 because we had a 1 4 already. Couldn't use a 5, so we'd have to have a 6 9. So it'd be 1 4 6 9 here. We'd have 1 2 3 4 5 6 and 8 9. So we'd have a 7 here. I hate having to do this, but so then here, these would need a 4 difference without using 2 5 8 or 1 5 9. So I could do 3 7. 4 8's not possible. Can't use 5 9. So this would have to be 3 7. Maybe this is sort of the key here. I'm gonna have to try this the other way. But then these can't be 4 difference, which I think could be done in several ways. Oh, the 4 would be here, so this wouldn't be the 1 4. So this would be the 1 4. So what's left in the column would be 2 6 8. We couldn't put 2 6 here. Which means 2 or 6 would have to be down here. And there's an 8 up here. That gives me my 8 9 pair. So that's all very much working, and I almost want to save that because I almost think it's going to be the case, but I'll remember. So I just have to try the other way around now. So let's try this as 4, or sorry, let's try this as 3 and this is 4. So if this is 4, then this has to be 951. And we need 2 more 4 differences without using 4. So we can have a 2, 6. Can we do 3, 7? Don't see why not. So we'd have a 2, 6 and a 3, 7. We couldn't do 4, 8, and we can't do 5, 9. So there's a 3 in here. So, oops, can't do 3, 7 up here. Can't do 2, 6 down here. And the remaining digit is 8. Okay. I'm sorry if there's an easier way to do this, but this is what I'm going with. I hope this actually does something for me. I hope I actually remember what those other digits ended up being. So now these need to have 3 difference. It can't start with a 1 here. So I think we said it had to be, because we can't have a 3 either. So it has to be 2, 5, 8. And we can have the 2, 8 on either side. This can't be an 8 though now. So that actually fixes it like this. And then what's the difference here? So this can't use a 1, can't use a 2, can't use a 3. Can we use a 4, 7? Looks like it. Can't have 5, 8, or 9. Okay. 4, 6, 9, I should say. So now the rest of the column would be 1 and then 6, 9. So we couldn't have the 6 and 9 together. So one of these has to be 6 or 9. There's a 1 up here. So both cases are fairly forced, but also work. Oh no. I'm just looking to see if anything here breaks with some other constraints that we're looking at here. Makes me wonder if I should have looked at somewhere else first, but I don't really know where else to look. This seems like the most obvious place. What could we do here? So there'd be one, 4, 6, 9 here. And this has to have at least 5 difference. So we couldn't be, for example, 4, 6. Couldn't be 6, 9. So we'd be 1, 6, 1, 9. 1 or 4, 9. One, 6, 1, 9, or 4, 9. That uses all 4 numbers. So I can't eliminate any. Okay, maybe what I should do is keep these filled and then also fill the other possibility. And see if there's more overlap that I'm not remembering. Okay, so I'm keeping this, and now I'm going to look at, okay, what if it were, should remember. I'll put the 3 4s back in later. What if it were 4, 3 like this? So we know that this would have to be 1, 5, 9. These both always had 5 in the center, for sure. I'm gonna, yeah, because 1, 5, 9 or 2, 5, 8. So that's something. So this was a 2, 8 here. I don't think those got eliminated in any way. Let's do this column first. This was the 3 column. So this was 2, 8, 2, 8 with a 5. And then that does put a 5 up here before I forget. Okay, so we were saying that these two could be, with a 3 difference, would be 1, 4, and then we can't repeat the 1, 4. We can't repeat the 4, can't use the 3, can't use the 5. So 1, 4, and 6, 9. And because this is one, in this case, this is 1, 5, 9, the 9 can't be down here. So this is the 1, 4, and this is the 6, 9. So there's always a 6 here. I am also thinking about, what if I did 4, 7 instead? Is there another 3 difference that I could use in that case? I don't think there is, because now I can't use 1, 4. I can't use 1, 4. I can't use 2, 5. I can't use 3, 6. I can't use, I'm already using 4, 7. I can't use 5, 8. Well, 4, 7 with 6, 9. 4, 7 with 6, 9 actually works. Luckily, I already have 4, 7 filled here. But this couldn't be 4, 7 either way. So this would have to be 6, 9 if this were 3 different. So if this is 4 different, it's 2, 6. And if it's 3 different, it's 6, 9. That forces a 6 up here, which actually eliminates this 6 here. It's interesting. Meaning this would be 6. That actually puts a 2 here, interestingly. But I haven't finished. Oh, I haven't finished this. So this column, the remaining digit in that case is either the 1 from the 1, 4, or the 7 from the 4, 7. If that makes sense. Okay, so this 4 column here, we'd have 1, 5, 9. This is getting really hard to keep track of. But so 1, 5, 9, and then 4 difference, we could do, well, we can't actually do anything with 2, because this is going to be 2, 5, 8. So we can't use 1 or 2. We could use 3. I think we said it could be 3, 7. So this is either 4, 7 or 3, 7, and it always has a 7. Let me check to see if there's other values, though. We can't do 5, 9, so, and that's it, right? We can't go higher than 5. So there's always a 7 here with a 3 or a 4. And then the 3 remaining values are 2, not 3, not 4, not 5. I believe it was 2 and then 6 and then 8. And this can't be the 2, 6. So that means 2 and 6 are down here somewhere. I think I erased something there. Let me undo. So this was a 6 already. Okay. Right, the 8 can't be down here because that would make that 2, 6. So in this case, it's going to be a 6 with a 1 or a 7. 6 with 1 is a 5 difference, and 6 with 7 is a 1 difference. Hopefully I did all that right. Over here, I'm not even sure what to put, so I'm just going to erase that. for now. So what did I learn? 1s are here, 7s are here, 6s are here. These are pretty limited. These are not so limited. Let's put the 3 and the 4 back in here. Wow. I really hope that that was what I'm supposed to do, even though it did take me a while to work through. Whatever 3, 4 is here, the other 3, 4 is here. Not sure what that means, but it's something. Wow, this is an incredible puzzle. I don't feel like I've really even made progress. I placed these 5s. These 5s tell me anything horizontally? Not really. They're not connected horizontally. There's the negative constraint, but I don't actually know what values are there. I haven't actually figured out which of these is 3 or 4. One of these combinations I recall did eliminate an 8 from here, but the other one didn't, so... If 8's not here, then it's here, in this box. Okay. What can I do with this information that I've just overloaded myself with? This row has 3 differences that don't use a 5. Does that mean anything to me? Not that I can think of. If the difference were 4, it would mean we couldn't do 1, 5. We'd have to do 2, 6, 3, 7, and 4, 8. Which seems fine. Oh wait, but the difference would be 4, so we couldn't do 4, 8. I know it's eliminating 1 out of 6 digits, but if this were a 4, what could go into these 3? We need 3 separate differences. So the 1 has to be here. So that would have to be 1, 5. Okay, so that's easy. That's not a 4. If this were a 5, this would have to be 1, 6. And then what would these 2 be? Oh no, it can't be 5. There's a 5 in the row. Easy. Making this too hard on myself. If this were a 6, then this would be 1, 7. Interestingly, placing a 7 here. And possibly determining our... I don't think... I'd have to think about that. No, it doesn't determine whether we're 3, 4. But the 1, 7 here, what would these 2 be? 2, 8, 3, 9. Seems to be okay. I think that's the only option, though, which would actually place a 4 here. So that's interesting, but not super useful. What about a smaller number, like 3? 3 would put 1, 4 here. Okay, so let's think about that. A 6 definitely eliminates... So that force, because there has to be a 1 here, so that forces 1, 7. And then we said it had to be 2, 8, and 3, 9. So if this is a 6, that eliminates a 3 from here. So let's remember that. oops, this can't be 5. If that's a 6, this can't be 3. Or 7, actually, so it has to be 4. If this is a 3, this obviously can't be a 3, but it also can't be a 4. Because we'd have 1, 4 here. So that would force that to be 7. So this would be 3, 1, 4, 7. And so what would these be? 2, well, we can't be 2, 5. Can't be 3, 6. We already have a 1, 4, so we can't be 4, 7. Well, we can't be 4, 7 for 2 reasons. We can't be 5, 8. So that leaves just 6, 9 for both of these. So this can't be 3. We're getting there. Oops, I didn't undo enough. There we go. That can't be 3. What if it were 2? If this were 2, this has to be 1, 3. So again, 3 is eliminated from here. Should I check the rest just to make sure I might as well? So we could have a 2, but we can't use 2. Can't use 3. We can't use 4, so we can do 4, 6. Can't use 5. We just used 4, 6, 6 in the 4, 6. So that would be 7, 9. 4, 6, 7, 9. So that would force a 4 into there. So far both 6 and 2 have forced a 4 in there. Interestingly. What about 1? The problem with 1 is we don't know what has to be here. Well, 1 means this can't be 4. That's unfortunate. Because, I mean, that's next to a 5, right? Actually, the 2, just by definition, removes the 3. Because of the negative constraint. Removes the 3 and the 7 by negative constraint. So 6 and 2 make a 4, and then 1 makes a not 4. Darn it. Is 1 possible? I mean, it seems like 1 is very possible to me. So 1 eliminates 4 from here. This is 3 or 7. Which actually does determine, that makes that a 3-7 pair. Because we can't have a 4 with a 3 or we could have a 4 with 7. Never mind. So we could have a 2, 3. That would eliminate 3. So that's interesting. Let's see if it's possible to not have a 2, 3. Because if we have to have a 2, 3, that still eliminates 3 from here. So that means all 3 cases eliminate 3 from here, which is interesting. So let's avoid doing 2, 3. Let's avoid doing 3, 4. Let's actually assume this is a 3. I think that's the cleanest way to do it, is if this is a 1, can this be 3? So we can't do 2, 3. Well, where does 2 go? That's the easiest question to ask. Where does 2 go if this is a 1 and that's a 3? 2 can't go here because it would be next to a 3 and there's no diamond. And 2 anywhere else would require a 1 next, or a 1 or a 3 next to it, and that's used up. So 2 can't go in either of these because there's no diamonds. And then a 2 in any of these, say here, would require a 1 next to it. In fact, the only place that, or a 3, and that they're both used up. So I think that means this can't be 3. So just go over that again. A 2 here, just by the constraint, prevents this from being 3, because we know that's 5. A 1 here prevents this from being 3, because if it were a 3, there'd be nowhere to put a 2 in the row. And a 6 here requires this to be 1, 7. And then one of these has to use then 3, 9. Because wherever we put a 9 in this row, I guess a good way to put that is wherever we end up putting a 9, it's got to be by a 3. Because it's on a diamond somewhere. So all that to say this can't be 3, and I really hope that means something. So this can't be 3. What's that mean for this diamond? So the difference is 3 or 4. So this could still be 3, 7 or 4, 7. Oh my gosh. I felt like I was pulling teeth there to find that can't be 3, and I don't even know what that did. It did something. Okay, well, both 4 and 7 are, well, 4 is 1 away from 5, and 7 is 2 away from 5. Does that mean anything to me? Not yet. It kind of means that if this is not 6, then this gets determined. Oh my gosh. Okay, well, this is a 1 or a 2, and this is 1, 2, or 6. So if the difference were 1, this would be a 1 puts a 2 or a 3 from the 1, 2. A 2 puts a 1 or a 3 or a 4. And the 6 puts a 5 or a 7. Well, this can't be 1. Okay, because of the row. Puts a 5 or a 7 or a 4 or an 8. This is still 2, 3, 4, 5. So it can't be 6. That's what we learned. This can't be 6. Yikes. Well, we certainly can't have an 8 here, because none of these numbers can have a difference of 8. Because 8 has to be 1, 9. Right. We can't have 7, because even a 3 or a 7 here can't have a difference of 7. So if this is 6, we'd have to go down to 5 or 4. Can it be 5? Well, if it were a difference of 5, then 3 would be with 8. 4 would be with 9. And 7 would be with 2. Well, we can't have a 9 there, so that would forbid 7. That would be interesting, but it's possible. So we can be 5. For similar reasons, I assume we can be 4. This, though, has to then also be able to do a 5, 6, or 7 difference. I don't know what that means. I don't think it means much. This is kind of interesting. Almost a triple. Not quite. Okay, does this mean... Okay. I didn't really look at the interaction here between these three. Oh boy, I mean, I could look at that. So this kind of forces this, which also kind of forces this. Let's run through it, because I got nothing better to look at. You're welcome to solve this in a different way yourself, but I'm going to look at 1 here, because that does some interesting eliminations here. So 1 forces a 2 here. We're not going to look over here, but that 2, this has to have a 2 difference. So that forces a 3 here. So that means this can't be 3, and this 1 difference means that this can't be 4 because of the negative constraint. So that puts a 7 here and a 4 here, which makes this difference 3. So this has to be 3, 4 like this. So that actually determines our order here. And we can fill out what that means. So that makes this 2, 8. That makes this 1, 9. Do any of these break our constraints? No? Oh, well, wait a minute. I've done all of this just to notice that this 3, 4 forces a 1 here. All right. Yeah. I'm sorry. These have a difference of 1. That forces this to be 1. That forces this to be 2, 4, 6. I don't think all this work was in vain, but it certainly was premature. Okay. Well, Didn't both 2 and... Yeah, everything eliminated a 3 from here, which was interesting. This has a 1 difference. That certainly limits what this can be. Can't be a 1 because of the row, so this has to be 3 or 5, and we said this can't be 7. And the reason it can't be 7 is 3, 4, and 7 all can't have a difference of 7 next to it. This certainly simplifies things a bit. Okay, well, if I put a 2 here, does that remove every possibility? I don't remember which of the 2s or 5s happened because of this. Like, this chain's hard to see, but I'm going to try a 2 here and just see what happens. There again, I might discover that I was missing something else, but... All right, 2. That forces a 1, 3 here. Yes, forces a 1, 3 here. And that forces a 5 here. That's not 1 different. All right, that's already easy. All right. This is 6, this is 5. 6 forces 1, 7. And then these had to be 2, 8 or 3, 9. This can't be 2. Which means this can't be 8. Any other eliminations? This 2, 7 forces a 4 here. That eliminates 4. Then we know that that 4 has to go with the 7. That's a 3 difference here, a 4 difference here. Boy, I wish I'd seen that earlier. I apologize. Okay, this is 3 different. So that's 8, 2 here, and 1, 9 here. We said, let's just redo this. So the last remaining in the column are 1, 3, and 9. And these can't have a 3 difference, which is perfectly fine. None of them have a 3 difference. By the way, just checking these. Okay. Sorry, don't get distracted. All right, 1, 3. Oh, wait, no, 3 is not missing. Something else is missing, not 3. 6 is missing. Right, and we can't have 6, 9 here. So that means 6 or 9 has to be down here. So this can't be a 1. So 1 is up here. And then let's redo these as well. So with a 4 difference, these have to be 2, 6, 3, 7. We can't be 4, 8 because there's a 4 in the column already, and there's a 5, 9 in the column already. So this is 2, 3. There's already a 3 up here, so this is 2, 6. We've done this before, but it feels like ages ago. So this is 3, 7 pair. This is a 2, 6 pair. That actually eliminates 6 from here. So that places a 6. We no longer can be 6 here. This should be placeable, and that should determine this one. So, well, I hope it's 2, because that's what's left. So is this an 8? Yeah, this is an 8, and that's a 2. All right, well, at least our previous work was correct. All right, so this is 6, 8. That puts a 2 here. None of these can have a 2 difference. There's no more diamonds. What can these 3 be? So 1, 2, 3, 4, 6. 1, 4, 6. Wait, where's my 9? Not 6, 9. 1, 4, 9. That means the difference here is either 8. Well, I guess it means it can't be 7, right? Because none of these have difference of 7. These have a difference of 3, which isn't possible. 8 or 4, 9 has a difference of 5. So this can't be 7. That puts a 7 down here somewhere. Because for the box, right? In fact, we can fill out what the rest of the box has to be. 5 and 7 and 9? No, not 9. 8? Yeah, 5, 7, 8. This 6 sees this. Okay. What else we got? This is, I'm guessing, oh, this can't be 9 anymore, and that's the difference of 6, so that can't be 3. This is 2, 8, or 3, 9. That looks correct. What is this triple? 2, 3, 6. Does this 5 difference? No, that 5 eliminates 4 from here. Okay, well these can't be 6 because of the negative constraint. Oh, this is placeable. That's a 2. So that's not 2. What's left here? 3, 4, 6, and 8. This can't be 6. This can't be 6. Be nice if this couldn't be 6, but I don't think that's true. This can't be 4. This 6, 4, see it. What to do next? I'm just trying to be careful that I didn't miss any diamonds that are giving away these values anywhere. This can't be 6, actually. I think I had noticed that before and then immediately forgot. So the 6 goes here. Problem is I don't have a way to mark can't be 6, right? So where does 6 go in this box? 6 goes down here. These can't be 6 anymore. That makes one of these 6, which I already knew, actually. If I had looked carefully at the 1 difference, one of them has to be 6. Because either 5, 6, or 6, 7. All right, well, I can... Let's move on. Let's keep going. So what is the most likely place to go next? We've got a few diamonds here, especially this one. This would give this a value. What are the possibilities? I mean, I might as well just... It's useful to have this column filled anyway. 3, 4, 7, 8, 9. And I think 9 we limited to these 2, right? So these can't be 9. So this is either 3, 4, or 7, 8. This, unfortunately, 3, 4, 7, 8 is... Okay, so this can't be 7. Any eliminations here? 3, 4, 7, 8, 9. This can't be 4. That makes this 3. Oop. Whatever I typed is not what I meant. These can't be 8. That's an 8. 3, 4. All right, some progress. Negative constraint doesn't help me there. Do I look at whether this can be is 3, 4 or 7, 8? I mean, that doesn't seem like... Well, this can't be 8. because that would put a 10 here. If that's not an 8, then that's not a 7. A 7 would put a 9 here, which seems okay. A 4 would put a 6 here. Also seems okay. And a 3 puts a 5 here. Still okay. 2 goes here, just because I just saw that. Just because these two eliminate that, and this 2 eliminates that. 3, 4 pair sees this. This is 2, 3. 6 difference puts a 9 here. This is now 2, 8. If the 8 were here, that can't be 7. What are these 3? For the box, we got a 2. Actually, yeah. That makes that a 2, 6 pair. Oh, no, wait. We don't have a 2 left in the box. The 2's here. Okay. What am I talking about? Nothing. 5, 6, 7. That's what we got. That looks okay. That's the same for the row. This can't be 6. This can't be 7 because of the negative constraint. So that's a 5. 6, 7's okay because that was a 3 or 4. All right, well, can the negative constraint tell me anything here? Yeah, this is 3 different, right? Simple subtraction is starting to fail me. That's what this puzzle's doing to me. But I do believe 2 plus 3 is 5. That means that can't be 3. It's a 4. 3. 9 can't go there. Things you learn. Also a 1 can't go there. All right, so well, 4 is eliminated from these. That means 3 is eliminated, and so this is 8, 7. I trust my marks. So one of these is a 9, one of these is a 3. So the question is, do we have a negative constraint removing 3 as a possibility? Not yet. We don't have 2 numbers next to each other at all. I feel like this is progress, though. 9s are limited here. Yep, already knew that. Come on, what else do we have? So oh, 7 difference here makes this a 9. That should be useful. That's not a 9. Okay, so 2 plus 7 is 9. I don't think 4 can have a 7 difference with anything. 4 plus 7 is 11. So this is a 1, and this is an 8. That's got to do something, right? That's no longer a 1. This has a difference of 5 or 8, and it can no longer have a difference of 5. So this is the 9. This is an 8. These aren't 8. These aren't 8. This is 4. Can eliminate these corner marks just to eliminate some of the extra stuff happening there. This row is pretty limited now. We got 1, 2, we need 3, 4, 5, 6. Oh, the 7 was placed. So that's 3, 7. I was getting a bit confused about how many digits were left in that row. This is a 4, 5, 6. None of which can have a 7 added or subtract. Obviously, you can't subtract 7. If we add 7, we start with 11 and go higher from there. So this is not a 7, which means this is not... Yeah. I don't think that means anything about this one. Okay. The 6 can go with 5 or 7, and the 5 can go with 6. But if we're 5 different, 5 or 6 different, I don't think we can use a 5. Is that true? Well, we certainly can't be 5 different from a 5. That goes to 0 or 10. Oh, we can be 5 different from a 6, because then we can be 1. So if this is 6, then that would be 1 with the 5. With a 4, we could be 9, but 9's used. So if this were 5, this has to be 6. I don't even know why I was doing 5 different from 5, because this is 5. That Sudoku eliminates the 5 from here. That's where my brain is right now. Apologize. We know 5's down here somewhere. It would be nice to prove that it's not on the diamond. So if a 5 were on the diamond, it would have to be with a 6. There's no way we're subtracting or adding that, so 5 goes here. All right. If we're a 5, that we'd have to be a 1 or a 9. Well, we can't be 9. So if we're a 5, we can't be a 4 here. It would be 6, 1. If we're a 6, we can't subtract or add. Well, 6 eliminates the 6, so that puts us with a 4. But we can't subtract or add 6 with a 4 either. Can't go to -2 or 10. So that makes this 6, 1. And this is a 5. That makes this 6, because it has to be 1 consecutive. All this is working. That's great. What's this 5 tell us? There's no more diamonds. What's left in here? 3, 4, looks like. That can't be 3. So we got 4 and 3. That works. For this column, we've got... Oh, we have the 1 placed. All right. Just got to scan better. 2 left in this column. And it's 2 and 4. This can't be 2, so that's 4 or 2. Have these been resolved? No? Okay. This is 7, 8. Doesn't look resolved to me. Oh, that is, because this 2 has a diamond on it. How long has that been there? So that has to be 8, 7. Don't tell me how long that's been there. This has to be 1. I'm just looking at the rest of the diamonds now. I feel like we're down to negative constraint in Sudoku, maybe? Looks like it. Any of these have a difference of 3? Not yet. All right. Get rid of this corner mark. Any of these have a difference of 7? If this were an 8, it would have a difference of 7. All right, let's just keep moving. This has an extra digit, and that's not 6. These 2 are a 2 and a 6. Tell me something's eliminated. No. All right. And then the rest of this row is 3, 7, and 9. This column is done. Looks like it has to be 7. Can't be too different from 7, so this is 3 and 9. Oh, we're on the home stretch. We got the 9. So this is 7, this is 9. Darn. I was hoping to get a 7 here so we could place the 8, but I'm sure we'll get it soon. This 7 places 6, 7, 2, 6. Don't stop now. this 4, so he's 5, 4. 5's in here somewhere. Let's just fill these in. For the box, we have 1, 3, 5, and 8. These aren't 5. 1, 3, 5, 8. These aren't 3, so 3 is here. Does that mean this is 2, or did I wait? Oh, 2's in this box. Okay, so this is 2, 8. That makes that one 3, and 5, 8. There must be more to this. All right, it's not a deadly pattern. None of the columns disambiguate with the negative constraint. Well, what about with themselves? No? So it must be that I have a 3 different somewhere. Or I'm forced to have a 3 different somewhere. What am I not seeing? Do I just try one? Sometimes I just try one. I hate to do it. I'd like to see the logic, but I'm sure if I just start filling in digits, I'll see it. But if I guess right, then that's kind of anticlimactic. Okay, so this 6, if this were 9, that would force a 3 here, but then this would be 3 different, and there's no diamond. So this has to be 1. That should do it. Yay, I didn't have to try. I didn't have to just fill a digit and try. 5, 7, 8, 5. Wow, what a puzzle. Took me a while. I don't even know what parts I'm going to fast forward in the edit, if any. I might just post this as is. I feel like my logic was sound. I just missed that 3, 4 for a while. I guess let me know how you like the long video, whether you prefer me to try to fast forward when I can, like I do in my previous live solves, or whether the hour-plus video is interesting. You feel free to watch at 2x speed if you don't want to spend an hour watching it. But yeah, so that was quite a good puzzle, Glum Hippo. Probably more difficult than I expected, but honestly, I made it more difficult than it had to be. Like this 3, 4, I eliminated. I got to that pretty quickly. Like I had to do some logic there, but I got that 3, 4 pair pretty quickly, and that should have immediately told me this was a 1. Everything I did after that was, I wouldn't say it was a waste of time, but I just made things so much harder on myself for not just thinking, oh, 3, 4, diamond, this is 1. And that might just be because I haven't done this constraint before. He does have 3 other puzzles. I wonder if they sort of teach you the constraint rather than diving in head first. But anyway, if you stuck around with this video, thanks for watching. Definitely going to be posting more in the future, as well as how-to solves for puzzles that I create, so keep an eye out. If you do want to see more videos from me, the best thing to do is subscribe so that you get notifications or it shows up in your feed, so that, because I don't really keep a strict schedule right now. So yeah, and I'll put boxes on the screen for other videos you might find interesting, and go ahead and check those out if you haven't. And until next time, thanks for watching.